Hello and welcome to the second video in this series. This is a follow-on from the previous video looking at areas and volumes of shapes. In this one, we're going to look specifically at some exam style questions, the kind of things you might get asked to do with the information in the previous video. So let's jump in. But before we do, just a reminder, please take notes as you go along and feel free to pause and go back if there's anything that didn't quite make sense. Fingers crossed it does. All right, let's go. Right, so building on what we did in the previous video, this is the sort of thing you might get asked to do. So in this case, we've been given a component, an image of a component, and we're told it's made from 15mm thick steel plate. We would then need to calculate the volume of steel used in the manufacture of this component. So this is relatively simple. There are a few things here that can trip you up. So what we're going to do is I will give you a few tips on these and then we'll move on to the next question. And then at the end of this video, we'll go through the answers and how they were calculated. Okay. So if you want to do this, pause me now. What I will just say is just be careful looking over here at the diameter and the radius. The icons that show these, you have a look at the little arrows. The little arrow on the line tells you which which line it's referring to. Okay, so this radius 15 is pointing at this line here, and this diameter 20 is pointing at this circle here. Okay, so pause the video, have a go, see if you can work this out on your own, and then we will look at the answers a bit later on. All right, how did you do? Hopefully, hopefully you've got an answer. Let's move on to the next one. We'll come back to the answers to these in a bit. So here's the second one, and this one, whereas the last one did have one sort of thing that people tend to trip up on, this one has got a second thing. In fact, there's two things in this one that people tend to trip up on. I will tell you what those are in the answer, in the big reveal at the end. But this situation here, we've got a copper component that's manufactured, that should be a D, from 2mm thick copper sheet. So calculate the volume of copper used to manufacture this component. All right. So the maths is the same as we've done before. There's nothing too complicated in the maths. Just be aware again, this is a diameter pointing at this circle, and this radius is pointing at this circle here. Okay. So have a look at the image, have a look at the technical drawing, and see if you can calculate the volume of this shape here. All right. So I will stop talking for a second while you pause me and have a go, and then we'll have a look at the third example. All right. Hopefully you've got an answer for that one as well. Right. Let's have a look at the next one, which in some ways is easier and in some ways is slightly more difficult. So this example here, what we're working out is the volume of this brass pin. So how much material is contained here, but also how much does it weigh? All right. So what I've done here is I've given you the mass of brass. So it's 8.5 grams per cubic centimeter, or it's 0.0085 grams per cubic millimeter. All right, because 1,000 of those go into one of those. So using what we've done before, find out the volume of brass that's used to create this pin and how much does one weigh. All right. So you'll need to work out the volume before you can then work out the mass. And what you do is you just multiply the volume of this by the mass per millimeter cubed. There's two ways you could do this. Actually, you could turn the whole thing into centimeters and work it out in centimeters cubed, but I would recommend you stay with millimeters cubed. Okay. So pause me again. Have a look, see if you can do this one. All right. Hopefully, you've got three answers to the three questions. What we're going to do now is we're going to go through exactly how to work out the answers to these. We're going to do the big reveal on the answers, and hopefully you've got the same as I've got. So the first example, this component here, 15mm thick mild steel plate. What is the volume? Well, I got an answer of 1,339.27 millimeters squared for the area. And for the volume, I got 20,089.05 millimeters cubed. All right. Hopefully you've got the same as me. If you have, great. You get it. You can probably tap through to the next example. But just to show you how I did this, what I did was I looked at this length here, 55, and this length here, 45, which tells me the difference between there and there is a 10mm gap. So I worked out the area of the triangle on the end by multiplying 30 by 10 and then dividing it by 2. If you remember, that's the formula for the triangle. And that gave me the area of this little section here. Then, to work out the center area, I treated from here to here as a rectangle, which is 45 wide and 30 tall. So 45 multiplied by 30 gives me the area of a rectangle that sits here. Okay. Then what I did was I worked out, okay, if there was a semicircle on the end, then I would do pi r squared divided by 2 because it's a semicircle. Well, the radius is 15 in this case. So pi multiplied by 15 squared divided by 2 gives me this area on the end. And then what I did was I worked out the area of these two cutouts and took those off. So I added up all the things I worked out so far, the triangle, the rectangle, and the semicircle. And then I went on to work out, right, well, what's the area of this circle and what's the area of this cutout, and take them off. Okay, this one's really easy. 10 multiplied by 20, which is 200. So I took that off. And then I did pi r squared for this circle here and took that off. Now, the trick, thing that can catch you out here, is it's giving you a diameter, but you want the radius. So the radius, excuse me, the radius in this case is 10. So I did pi multiplied by 10 squared, and then took that away from my area. And then the last thing I did to work out the volume is once I had an area for this shape here, I just multiplied it by the 15 millimeters to get the volume of the shape. All right. So hopefully yours is the same as mine. If not, and you didn't get the same, then have a go at doing it the way I did it, and hopefully you'll get to the same answer. But this is all about visualizing what shapes have been stuck together here in order to create this more complicated shape. So how can you break down a problem like this into really simple shapes? So all I did was a triangle, a rectangle, and a semicircle, a circle, and a rectangle, and took those off. Okay, hopefully that makes sense. Let's have a look at the second one. Actually, before we do, the thing that trips up people here, there's two things that were the big trip ups. Number one was being given the diameter instead of a radius. And the second one is people will calculate the areas of these two shapes here, but instead of taking them away because they're cutouts, we'll accidentally add them on. All right. So just be careful that that's not something you did and hopefully didn't do in the next example. So here we've got that same kind of trip up as last time where we've been given a diameter. And also, the other thing that trips people up is the fact there are two circles cut out here. So what people will tend to do is they'll calculate the area of this circle and take it away from the area of the face, but they'll forget there's two of them. So they'll forget to take this one away as well. All right. So let's have a look. The area is 2,406.33. And the way we calculated this was, well, break this down into simple shapes. What we got here is effectively one big rectangle in the middle, two semicircles on the end, a cutout that's a rectangle, and two cutouts that are circles. So the way I treated this, because there were two semicircles, I just treated it like one circle. So first of all, I did 75 multiplied by, how wide is this? Well, here's another trip up. So because we know the radius of this circle is 15, then it must be 30 all the way across as its diameter. So that's the width of the shape. So it's 30 across. Okay. So 75 multiplied by 30 gives me the area of this rectangle in the middle. And then pi r squared to work out this semicircle. Now I'm not going to divide it by 2, as you would think, because there's one over here. So if I just do pi r squared, it works out this one and this one. So the radius is 15. So I'll do pi multiplied by 15 squared, gives me the area of this semicircle and this semicircle. Okay. Right. Next thing to do then is to take away this area. So I worked out the rectangle in the middle and the two semicircles. Now I want to start taking off the bits that are being cut out. So 45 multiplied by 10 will give me the area of this cutout, and I'll take that away. And then I need to do pi r squared twice because there's two circles here. So the diameter is 8, which tells me the radius is 4. So I'll do pi multiplied by 4 squared to work out this circle, and then times that by 2 to get the area of this circle as well, and take that away to get, hopefully, the final area like this. And then, to work out the volume of this shape, all I do is work out how thick it is. I've made that same error again. Work out how thick it is. So it's 2 millimeters thick. So I just take the area and I multiply it by 2 to get the volume. Now, another area where people tend to trip up is on very thin components like this. So in engineering exams, you will very often get asked to calculate the volume of something that's very thin. It's really easy to miss the thickness of this when you're calculating it. And it's so easy just to go, oh, calculate the area, and then forget to multiply by that very thin thickness to get the volume. So just be careful of that. Hopefully you didn't do this when you were having a go earlier. And hopefully when you had a go, you managed to work out that the distance across this rectangle was 30 because of the radius of this semicircle. Okay. If not, I suggest having another go, working through it to try and get to the same answers. Hopefully I haven't made any mistakes, and hopefully yours will look the same as mine. Right, the final example then, let's have a look at the brass pin. So this is quite a chunky brass pin. So it's 100 millimeters long, or 10 centimeters. It's 60 millimeters across, so it's quite a big thing. And we were interested in working out the mass and the volume. So the volume is 106,814 millimeters cubed, and the mass is about 907 grams. Okay, so nearly a kilo. And the way this is calculated is by working out the volume of this pin here, the sticky outy bit at the front, and then working out the volume of the piece at the back, and then just adding them together. So if you look at this diagram here, looking from the front of this shape, you have got a diameter on the inner pin of 20, and you've got a radius on the outer part of 30. All right, so let's just look at this bit on its own. So what we do is, first of all, work out the area of this circle, and then multiply it by the length to get the volume. All right, so we would do pi r squared. So in this case, the radius would be 10 because it's half the diameter. So we would do pi multiplied by 10 squared, and that gives us the area of this face. And then multiply that by 70. All right, and then write that down somewhere. The second part would be, we need the area of this circle. So it's pi r squared again. So in this situation, we've been given the 30 as the radius, which is helpful because it's one less step. So we do pi multiplied by 30 squared, and then multiply that by this length here. And you can see if this is 70 and this is 100, then the difference must be 30. So pi times 30 squared multiplied by 30 gives us this end part. And when you add those two together, you should get this. Okay. And then to get the mass, all I did was take the volume of this 106,000, and multiply that by the mass per millimeters cubed. So the mass per millimeter cube was 0.0085 grams. If you take that and multiply it by this number here, you get the mass of the component. Okay. Which seems like a lot, nearly a kilo for this pin. But I did double check it in Fusion 360, and it was close enough. All right, so those are the answers to those questions. Now, like I say, if there's any of those that you didn't get right, I recommend you go back and work through them step by step to make sure you do get the right answers. And it'd be worth making a flashcard or something for each of these, pointing out the things that could potentially trip you up, like the fact there's two holes and the thickness, and just make sure that you've got that for revising for when you do an exam. Okay, that is me done. That is the second video. In the next one, what we'll do is we'll look at some different maths questions that tend to pop up in engineering exams at GCSE level. Things like proportion and how many things can you cut out of or whatever. But that will be coming soon. All right. Thank you very much.